Hi Geometry, this is Unit 5, Lesson 8, page 569 in our workbooks. So let's take a look at this problem 1. It says the image shows a cone with a base area of 36 pi centimeters cubed. That'd be the little one on top. The cone has been dilated using the top vertex as a center. So this was my center, and everything was pushed out, pushed away, dilated from that red center. It says the area of the dilated cone's base is 729 pi centimeters squared. So basically what happened was my little cone got bigger. So I do know that my scale factor was something bigger than 1 because my cone got larger. So it says, what is the scale factor of the dilation? So let's take a look at how to calculate that. This would be my original area. It's area because they're telling me the area of the circle on the bottom. And this is my image area. It's the one that comes after. So I'm going to use my area equation. Remember, the image area equals, this is k squared times my original area. And so now I'm going to fill in what I know. I know the image area is 729 pi. I know that the original area is 36 pi, and I'm trying to find my k. I'm trying to find what k is. I don't know that value right now. So in order to solve for k, I need to isolate it. So I'm going to divide both sides by 36 pi. Pi is just a number. And so I'm just going to bring it on over here with the 36. It cancels on the right side, and I get k squared isolated. That's fantastic. On the left side, the pi's cancel. It's 3.1415, blah, 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 and they just cancel. And I do 729 divided by 36 on my calculator, and I get 20.25. Now I need to solve for k. That means I need to cancel it being squared. We know that we're going to do that by taking the square root of both sides. When I do that, I find that my value for k, for my dilation, was 4.5. So let's take a look at the next page. I want to look at this jumbo can problem, and it says a beverage company manufactures and fills juice cans. It spends 0.04 cents on materials for each can. Okay, so the materials is the surface area of the can. It would be the metal or the aluminum or the cardboard or whatever packaging is creating the outside. So this is really an original area cost. That's an original area. It fills each can with 0.27 cents worth of juice. So if you think about the juice would then be my original volume inside my can. So that's my original volume cost in this problem. So the marketing team wants to make a jumbo version. They want to make a bigger version. They're going to dilate this and make this larger. They can spend at most 16 cents on materials. So remember, the materials make the outside of the can. So this is my image surface area, my image area cost. And then it says there's no restriction on how much they can spend on juice to fill it. So it all matters on how much area increases. The juice, they just are going to fill it till it fills. The team wants to make the new can as large as possible given the budget. By what factor, so what scale factor, I'm going to be looking for a k, will the height of the can increase? So the height's going to increase. The height is the dimension. My dimensions linked with height, perimeter, all increased by k. So again, I need to find my k. So the only way I can find k is by using one of my equations. And in this case, since I know the original area and I know the image area, I'm going to write an area equation. That's going to allow me to solve for k, because I know my image area equals k squared times my original area. So let's fill in what I know. My image area is 0.16. My original area is 0.04. So now I need to solve for k. I'm going to divide both sides by 0.04. So when I do that, I get 4 equals k squared. And so now I'm going to take the square root of both sides to isolate k, and I find that my scale factor is 2. That means the height of the can will double. The height will double. Remember all of my dimensions: height, width, length, perimeter. The dimensions change by k. Areas change by k squared. Volumes change by k cubed. So my height will double. My k will be 2. Let's go on to the next page. By what factor will the radius of the can increase? So if you think about that, your radius is just another dimension. So my radius will double as well. The radius will double because my scale factor is 2. Everything doubles. The radius, the height, the perimeter, the circumference, whatever dimension I have is going to double. The area of my can, surface area of my can, the area of the bases, my areas will change by k squared or 4, and my volume is going to change by k cubed or 8. So it says create drawings for the original and jumbo can. So my original can is something little, and then it doubles. So my image can should look like it doubles. So then this dimensions of this would be h, and my base would have a little r, little radius, and my image can, the height would be 2 times higher, and my radius would be 2 times the original radius. This would be my original little can, and this is my image, or my can that has been doubled in size. So then it says, what geometric solid do the cans resemble? Well, mine resemble cylinders. So I suppose your answers could vary, but I was thinking of a can looking like a cylinder. You could probably think of this as a juice box, but then you would have length and width dimensions, length, width, and height, that all doubled. So 5, it says, what will be the total cost for materials? That's my surface area. This is my area. And the juice. Now we haven't calculated anything with juice yet. So this is like my volume. This is what's going to fill it up. So let's think about my materials. Well, I know my materials from the previous page. It said my materials at most can be 16 cents. So that's from the problem on the previous page. I need to add to that my volume. So my volume cost, that's the volume to fill the juice. So let's figure that out for a second. My volume, my image volume would be k cubed, or 2 squared, or 2 cubed, sorry. My k cubed, my k is 2, times my original volume. And your original cost to fill the can was 27 cents. If you need to flip your page back, you can. But you'll see that we underline the 27 cents and call it my original volume. So my image volume, the cost of the juice, is 2 cubed times my original cost to fill this. And that would be $2.16 when you put it into your calculator, 8 times 0.27. And so that's $2.16. So when you add those together, it looks like the cost is going to be $2.32 for each of those cans. It says describe any other factors that might cause the total cost to be different from your answers. And here you could have lots of answers. Your answers will vary. But one of the things I was thinking is construction costs. I mean, we really don't know how much does the machinery cost to run? Is there a labor cost for workers to do this? Things of that nature will affect it. So flip again, please, to the summary on the next page. This summary just brings home what we've been learning. If you would pause this video for a moment and read about the aquarium, and then come back, please. So you read about the original aquarium, and it's been dilated by a scale factor of 3 for these new dimensions. So the new height, the new length, the new width, these are my dimensions. Notice they all change by k. My dimensions change by the scale factor. They're 3 times bigger than the original. However, my surface area, when I calculate my surface area, that changed by k squared. You can see the 9 right here because my areas changed by my scale factor squared. And you'll notice that my volume, when I calculate my new volume, it changed by my scale factor cubed. 3 cubed is 27. And that brings us back to what we've learned this semester. My dimensions, my original perimeter, length, width, dimension, radius. I'm sorry, I meant to say image. My image, perimeter, length, width, radius, my dimension changes by k times the original. My image area, that would be the area of a base, the area of a side, the surface area of my container, changes by k squared times the original area. And then finally, my image volume changes by k cubed times the original volume. These are our 3 equations we've been using over and over in our problems. So flip to the next page, and we're going to look at some of your practice problems on page 573. I'd like to look at number 2. These are what I'd like to call 2-step problems. You really have to do 2 things in order to solve it. So let's read about this. It says a board game manufacturer wraps its game boxes in plastic. If you can imagine, this is talking about surface area. You're wrapping plastic around your box, the outside of the box. Its most popular game comes in a box that's 8 centimeters tall. So this is a original height and uses 1,408 square centimeters of plastic wrap. So this is an original area. So I have an original height, that's a dimension, and I have an original area. So the company sells a travel size version of the box that's dilated. You can imagine a travel size would be smaller. This is going to get tinier. And I can see that because it says it uses 198 square centimeters of plastic wrap. This is my image area. And notice it's smaller. It uses less plastic. It says, how tall is the travel version's box? So I know how tall my original one is, but I don't know how tall my travel version is. So I need to figure out my scale factor. I need to know what k is. K equals what? Because my dimensions, my height, my width, my length, are going to change by k. My areas are going to change by k squared, and my volume, which has nothing to do with this particular problem, is going to change by k cubed. So I need to, step 1, I need to find k. I need to figure out what k is. Step 2 then, I need to figure out what my image height is. So let's first figure out k. The only way I can figure out k is using my area equation. I'm told the original area and I'm told the image area. So I'm going to use those. So let's set up our equation. Our equation is that my image area, which is 198, equals k squared times my original area, which is 1,408. I'm now going to divide the 1,408 over. I'm doing this to get my k squared isolated. So my 1,408 cancels on the right. When I do my division, I get 0.1406. Now I've run out of room, so I'm going to move this just over. So when I do my division, I get 0.1406 equals k squared. Now I'm going to solve for k by taking the square root of both sides. And when I do that, I find to get 0.375 for k. This makes sense to me. That is a number less than 1. And it makes sense because my box is getting smaller. My travel version's smaller. It makes sense that my scale factor is a number less than 1. So step 2, let's find my height. I know that my image height is equal to k times my original height. That's how my dimensions change. So I know that my image height is equal to my scale factor, 0.375, times my original height of 8 centimeters. When I multiply 0.375 by 8, I get 3. And so my travel box would be 3 centimeters in height. Thank you.